Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Control System Engineering. So friends, as far as this session is concerned, so we will try to learn the stability criteria whose name is nothing but what? The Routh stability criteria. In that previous session already we had discussed the first stability criteria adopted by this control system engineering phenomena whose name is nothing but what? The Hurwitz stability criteria. In this Hurwitz stability criteria we are supposed to declare one Hurwitz determinant, but as the degree of S increases, so the overall complexity of this Hurwitz criteria will also get increased. So in order to remove the complexity of this Hurwitz criteria as the power of S increases, this Routh stability criteria is being preferred over this Hurwitz stability criteria. So in order to start our journey towards this Routh stability criteria, first of all we need to understand similar to this Hurwitz criteria, such type of transfer function we used to have with us, right? And when the denominator of this transfer function is being equated to 0, so this entire term that can be called it as a characteristics equation, because whether it is Hurwitz criteria or whether it is Routh stability criteria, the characteristics equation plays very important role in these two stability criteria in order to determine the overall stability of that control system. So when this denominator term is being equated, the denominator term is nothing but what? The first coefficient of this s raised to n term is nothing but a0 times of s raised to n plus a1 times of s raised to n minus 1 plus n number of terms we used to have with us, which are being written in the descending order, right, along with positive or negative sign. So when this term is being equated to 0, so the next step what we need to do is, whenever it is required for we people to determine the overall stability of that system, so by adopting the basic strategy belongs to this Routh stability criteria. First of all we need to declare one Routh array, because just similar to the Hurwitz determinant, in this Routh stability criteria we are supposed to declare one Routh array based upon the coefficients of this characteristics equation, right? As we know, in case of this Hurwitz criteria, the size of this Hurwitz determinant is nothing but what? N cross n, most of the time, from sake of this transfer function notation, because in its denominator, as we are having the n number of different coefficients, right? So as we are having the n number of different coefficients, so the size of this Hurwitz matrix depends upon the highest power of this S term. So here the highest power of this S term is nothing but what? N. So n cross n Hurwitz determinant we need to declare. But as the power of this S increases, so this overall complexity of this Hurwitz criteria is being also increases. So in order to remove that, what we need to do, such type of Routh array we need to declare, and we are supposed to define the elements of this Routh array. So before defining the desired elements of this Routh array, first of all what we need to do, first of all from sake of observation we need to observe here the highest power of S term is nothing but what? S raised to n. So in this descending order we need to write all this S term like S raised to n, S raised to n minus 1, S raised to n minus 2 up to S raised to 0, right? Then after that we are supposed to declare the elements belongs to each and every row of this Routh array, right? So in order to declare the elements belongs to this S raised to n row, what we need to do, we need to collect all the coefficients which are lying at even position of this characteristics equation, right? Even position means what? The initial count always begins with this A0. So A0, A2, A4, A6, A8, all these are the coefficients which are being placed at that even position. So we need to collect all these coefficients in order to complete that, or in order to write the elements belongs to first row. So the elements of that first row will become what? Here I will write. Elements of this first row will become here A0, A2, A4, A6 like this. Now as far as the second row is concerned, the multiplying factor for this second row is nothing but what? S raised to n minus 1. So for that purpose we need to collect all the elements which are lying at that odd position, A1, A3, A5 and A7, right? As far as the S raised to n minus 2 or S raised to n minus 3, these two rows are concerned, so here these elements are to be written B1, B2, B3, C1, C2, C3, right? So such type of Routh array we need to declare, right? Now as far as the first two rows are concerned, so these two rows are to be declared with the help of this characteristics equation, right? And as far as this remaining or this lower two rows are concerned, which consist of these elements B1, B2, B3, C1, C2 and C3. So that is important for we people to understand how these unknown elements are to be tabulated. So for that purpose here I will write, this will be B1, this will be B2, and here I will write this B3 fellow. Similarly C1, C2 and C3, right? So this B1, B2, B3 elements belongs to row number 3. So in order to determine the elements belongs to row number 3, the first two row elements are being taken into account, right? In order to tabulate this B1, such type of cross multiplication is to be done. A1 into A2 minus A0 into A3 divided by A1. So in this way, this B1 is being tabulated. For sake of moment, I will remove all these three elements which we are supposed to declare. Here I will write B1 equals to A1 times of A2 minus A0 times of A3, this whole term divided by A1. Similarly B2, right? As I told you earlier, B1, B2, B3 belongs to row number 3 elements. So first two rows are being used in order to determine these three elements. So B2 equals to, in same way, the way in which we had tabulated this B1 fellow, here B2 equals to A1 times of A4, here A1 times of A4 minus A0 times of A5 divided by A1. In this way, by doing such type of cross multiplication, so it will become A1 times of A4 minus A0 times of A5 divided by A1. Similarly B3. In order to tabulate this third element belongs to row number 3. Again, one more time, this A1 will multiplied with this A6 minus A0 times of A7. So it will become A1 A6 minus A0 times of A7 divided by A1. Similarly, elements belongs to row number 4. These elements are nothing but what? C1, C2 and C3. So the way in which B1, B2, B2, B3 are being tabulated with the help of first two rows. Now C1, C2, C3 are to be declared with the help of row number 2 and row number 3. So in order to tabulate this C1, this B1 will get multiplied with this A3 minus A1 times of B2 divided by B1. So C1 equals to B1 times of A3 minus A1 times of B2 divided by B1. Similarly, C2 and C3. How to tabulate this C2 fellow? So in order to tabulate this C2, this B1 times of A5 minus A1 times of B3 divided by B1. This B1 times of A5 minus A1 times of B3 divided by B1. Similarly, the last element belongs to row number 4, whose coefficient is nothing but what? S raised to n minus 3. In order to tabulate this C3 fellow, one more time, this B1 is being multiplied with this A7, right? This B1 is being multiplied A7 minus, here if suppose we are having this B4 fellow, so here C3, how to tabulate this C3? This B1 times of A7 minus A0 times of B4 minus A0 times of B4 and this whole term divided by B1, right? So in this way these elements are to be tabulated. Then for what purpose we are doing all these things? In order to determine the overall stability. So at what point we will come to know whether that system is stable or unstable system. So for that purpose we need to observe all the elements belongs to first column of this Routh array, right? If all elements are positive or if all elements are denoted with the same sign, so at that time definitely we can say that that system is a stable system, means all the roots are lying towards the right hand side of this S domain representation. Sorry, all the poles are lying within the left hand side of this S domain representation, because this is the basic condition for the stability of that system. If all roots in the sense all the poles and zeros are lying towards the left hand side of this S domain, because see this is the real and this is the imaginary axis. So at that time definitely we can say that that system is a stable system. So this is how this Routh criteria is being used. So with the help of one example we will discuss the basics of this Routh criteria. Okay friends, so this is the targeted characteristics equation which we are having with us. Means our objective is to decide whether the given system which is denoted in terms of this characteristics equation is a stable or unstable system by means of this Routh stability criteria, right? So as I told you earlier, in case of this Routh stability criteria, we are supposed to declare one Routh array here like this, and we need to declare the elements of this Routh array. So before declaring the elements of this Routh array, first of all we need to map the given characteristics equation in terms of different coefficients. So we will start our journey with this first coefficient, starting with this A0. This will be A1, this will be A2, this will be A3, and this will be A4, right? Then after that, from sake of observation, we need to observe the highest power of S which is present within this characteristics equation is how much, right? So similar to that Hurwitz's criteria, this coefficients of this characteristics equation is to be written in descending order, starting from S raised to 4, S raised to 3, S raised to 2, S raised to 1, and S raised to 0. So obviously the highest power of S is 4 here, right? So accordingly S raised to 4, the multiplying factor for the first row for this Routh array, S raised to 4, S raised to 3, or here I will write S raised to 3, S raised to 2, S raised to 1, and last is nothing but what? S raised to 0. So in this descending order we need to write all this S term. Then after that the first row is concerned of this Routh array. Which elements we need to consider? All the elements which are lying at that even position. So starting from this A0, A2, A4 and A6, A8 like this. So the coefficient for this A0 will be what? This will be 1. A2 will be what? The coefficient of this S square is 4. A4 equals to 8. We don't have this A6 term, so no need to consider this A6. Then within that second row we need to collect all the elements which are lying at that odd position, starting from A1, A3, A5 like this. So A1 equals to what? 2, A3 equals to 6, A5 equals to 0, right? So this will be B1, B2, B3, B1, B2, B3, this will be C1, C2, C3. So how to get this B1 fellow? According to this Routh stability criteria, in order to determine these three elements belongs to row number 3, first two rows are being taken into account. So to decide this B1, this cross multiplication is to be done. So 2 4s are 8, minus 1 6 are 6 divided by 2. So B1 equals to what? 8 minus 6 divided by 2. So B1 equals to 1. Similarly, B2 equals to what here? B2 equals to this B1, B2 equals to this 2 into 8, 8 2s are 16 minus 1 into 0, 0 divided by 2. So 16 by 2. So B2 equals to 8. As far as this B3 is concerned, so in order to tabulate this B3, this we don't have this further term, so obviously B3 equals to 0. B3 equals to 0. So we need to substitute this B1, B2, B3 at this third row. B1 equals to 1, B2 equals to 8, B3 equals to 0. So here this C1, C2 and C3. C1, C2, C3 belongs to row number 4. First, second, third and fourth. Right. So C1 equals to what here? C1 equals to, in order to determine C1, C2, C3, row number 2 and row number 3 elements are being taken into account. So 1 into 6, 1 6 are 6, 8 into 2, right? So 8 2s are 16. So this 6 minus 16 divided by 1. So it will be minus 10, right? C1. As far as C2 is concerned, so in order to tabulate this C2, 1 into 8 minus 2 into 0 divided by 1, right? So here C2 equals to 8. What about C3? C3 equals to 0. So here I will write this C1 equals to minus 10, C2 equals to 8 and C3 equals to 0. As far as this last element is concerned, so in order to determine this last element, previous two rows are being used along with this cross multiplication. So it will become minus 10 into 8, minus 10 8s are 80, right? 80 minus 8, 72. Here I will write 80 minus 72 divided by minus 10. So which exactly equals to 80 minus 8. Here cross multiplication is 8. 80 minus 8 divided by minus 10. So minus 72 upon 10, right? So definitely we will have a certain negative value in this Routh array. So which exactly equals to what? 10 7 are 70. So 7 point minus it will become plus. So it will become plus 7.12 like this, right? So here we need to write this desired element 7.12, whatever it may be, right? Then after that, in order to decide the stability of that system, what we need to do? We need to observe all the elements which are lying at first column of this Routh array. If all elements carry the same sign at that time, that system can be called it as a stable system. Otherwise, that system can be called it as an unstable system, right? So as far as that first column is concerned, so within that first column there are 5 elements. Out of that 5 elements, 4 are positive, 1 is negative, means this system is unstable. In order to have the relative desired stability, all elements should carry the same sign. So as we are encountering with this sign change for 2 times, because see, from 1 to minus 10 first time, and from minus 10 to plus 7.12, whatever it may be, right? Means for 2 times we are going through this sign change phenomena. So when we plot such type of quadrant here to determine or to decide how many number of poles we are having to the right hand side of this S domain representation, because if we are having the desired number of roots to the right hand side, that system is an unstable system, right? So as we are going through the sign change for 2 times, so there are 2 roots which are present to the right hand side of this S domain representation. Obviously that system is nothing but what? The unstable system. So in this way, this Routh stability criteria is being used to decide the overall stability of that system. So I just hope that you had understand all these basic terms belongs to this Routh stability criteria. Thank you.